Section 3.4 today, and in 3.3 we've talked about parallel lines. This section's all about perpendicular lines. So in your electronic notebook, go ahead and write the definition for a perpendicular bisector. And what that is, it's a segment that's perpendicular to another segment at that segment's midpoint. And we're going to construct these in class. It's really simple. I think you could follow the directions pretty simply if you wanted to try this at home on your own paper. But we're going to practice doing perpendicular bisectors. We will do that in class, so don't worry if you don't have your stuff with you. We will do this tomorrow or our next class day, whenever that is. All right, now towards the bottom of that, this is what I want to focus in on. So if you'll put a nice big box around this, because this is important information. The shortest segment from a point to a line is perpendicular to the line. This fact is used to define the, and then you can see they highlighted it for you, distance from a point to a line is the length of the perpendicular segment from the point to the line. So if you want to know what the shortest segment is, it's the perpendicular one. That's going to be the shortest distance from any point to a line. If it's dropping down perpendicularly, not at any other angle, but straight down at forming a 90-degree angle, that is the shortest distance. Okay? So let's flip the page and let's apply what you just learned here to this particular section. I'm going to watch me do examples 1A and 1B, and then you're going to do check it out 1A and 1B, okay? Now the first one is purely identification based on what I just said. Based on this figure right here, what is the shortest segment from point P to line AC? Now hopefully you're telling me segment PB. And that's right, that is the shortest segment right there, okay? It's forming a 90-degree angle. It is perpendicular to that line. PC is not, and PA is not. Those are pretty long lines if you look at them because they're forming a much different angle. But P dropping straight down to that line, PB forms that perpendicular line that we're looking for. Okay, now B's a little weird. Pay attention real quick, really dial me in, and we're going to write and solve an inequality for X. Now notice our X is located right here, and X is part of the length of PA. And we know the length of PB. Okay, now what we do know is we're going to take the information we just learned from A. PB is the shortest segment there. Okay? We know that PA has to be bigger. Has to be bigger. There's no way that it's smaller. PB is the smallest, and so that means any other segment there is bigger. So what we'll do is we're going to create an inequality. PA's length is X plus 3. That has to be bigger than PB's length, which is 5. Okay? And then we're going to solve the inequality. And we know that X has to be a number that's bigger than 2. Cannot be a number smaller than 2. It has to be a number bigger than 2. And so that's the gist of it right there. Okay? It's not meant to be tricky, so I'm sorry if you're like, what just happened? I'm not sure what just happened. It's really super basic algebra is what we're doing. We're using our logic and we're saying, hey, if PB is the shortest segment there, then all the other segments have to be bigger. So we created an inequality and said PA has to be bigger than PB. And then we inserted their lengths and solved for X. I'm going to give you 2 points, one for each of these examples that you're doing under Check It Out. A point for 1A and a point for 1B. And just do the best you can and see what you can do with it, okay? And we'll check them in class tomorrow. Thanks for listening.